Yes, today I'm going to show you how to run Llama 2 with 32,000 tokens of context length. Now, I'll show you a way to do it for free with a smaller context. To run with the full 32,000, you'll need to pay roughly about 70 cents to 150 per hour to rent a GPU, and I'm going to show you how to do that. Let's start off by running it in Google Colab, where on a free notebook you can get 8,000 tokens, and I'm going to show you how to get 16,000 tokens. Let's get started. I'm here on github.com/Trelis research, and I'm going to go to the repositories and click on Code Llama 32K. Now, if I click on this IPYNB notebook, it's going to load up and I can click Open in Colab. Now, I'm going to click on Runtime and I'm going to click Run All. It's loading from GitHub. Just a note here that if you want to run as a free notebook, you should click on Runtime, change runtime type, select a GPU or T4, and that will allow you to get 8K of context. I'm going to run with the A100, which will give me 16K context, and I'll show you or have shown you on RunPod how to get a full 32K of context. So I'm just going to click OK here. Okay, so the notebook is running and we're installing all of the requirements. I'm going to upload a file here, a large file, just so that we have some context to work with. It's a summary of the Berkshire Hathaway 2023 meeting, and it's got over 70,000 words in it. We can have a quick look at the file here. Taking a time to load. Yeah, so here we have the transcript, the Berkshire Hathaway 2023 meeting. You can see it's a really long file, about 4,000 lines. So as I said, about 70,000 words. Now the installation here is done, pretty quick process. And we're using the Blokes GPTQ model that allows us to quantize, which saves us space, allows us to get more context. And we're also using BetterTransformer, which allows us to use flash attention. I'll talk about that in a mini lecture at the end of this video. You'll notice that flash attention has been installed right up here. Now, scrolling down, we should be downloading the model. So here's the model, and it looks like the model has been downloaded. It's about 4 gigabytes in size, and we're moving hard to streaming. Notice that I'm shortening the text to 16,000 tokens. You can adjust that to 8,000 if you're running in a free notebook. And here we are. You can see we've already gotten a 3-bullet summary of the context. So we're here live in Nebraska. This is literally the 16,000 token snippet. And here it's just produced the 3-bullet summary. Just in case you want to see that again, let's click load. So here we have the 3-bullet summary about the Berkshire meeting, and you can see it's streaming live. All right, that's it for Google Colab demo. I'm going to show you how to run Llama on a server with 80 gigabytes. It'll be an A100, and it's going to allow us to reach those 32K context limit. So here, I'm going to click login, check for one of the A100s. This here with 48 is a bit cheaper and probably would get you 32K, to be honest. So you could go with that, but let's just go here with this option. We're going to continue, and it'll say Start Jupyter Notebook. So we just click there on Continue. And click on Deploy. I have my pod up and running here, and I'm going to click Connect and then go to the Jupyter Lab tab here. Now, Jupyter Lab has just opened up. I'm going to go to my workspace, and here what I'm going to do is upload the files. So I've got the Code Llama 32K, and I'm also going to show you a pro version that will allow you to easily upload, save chats, re-upload chats, upload documents. I'm here in the Llama 32K notebook, and just before I start, I'm going to scroll down here, and I'm going to adjust the number of tokens to 32,000. And I'm going to do kernel and restart and run all cells. So let's head back up to the top of this notebook, check the installation progress. Here we're installing Flash Attention again, just as we did in Colab. And we're going to download the Blokes model. Now the model will download and it should be visible on the left-hand side. It's about 4 gigabytes in size, as we previously saw. And what's happening once it's downloaded is the shards will be loaded onto the GPU. When you head over to see your pods, you'll see that your CPU is doing a lot. It's doing a lot of work. And once the shards are loaded, the CPU will bounce down and the GPU will bounce up. Okay, so you can see here that we are able to reach the context length on the 32K model. However, the accuracy is not the best. We're seeing some hallucination here at the start. And we do see a somewhat relevant response, but not exactly what we're hoping for. So I'm going to rerun this notebook now, but with some changes. This time around, I'm going to run with a different model. So instead of running with the 7B model, let's increase this to a 13B model here. 13B model, we can get even more quality. Now note that I'm not going to run for the full 32 context length. It's going to be hard to run that long of context length because I'm using a larger model. So instead, I'm going to reduce this down to 16. So let's just kernel, restart, and run all cells. Here we're downloading the tensors. This is a larger model because it's 13 gigabytes. 13 billion parameters, so about 7 gigabytes in size. We can see we're taking up more of the disk volume. Okay, the model is now downloaded and it'll now be loaded into memory. So we can see we've taken up more of the disk and our CPU usage is going to go up as we load the shards. And once the shards are loaded, this will drop and the GPU memory will go up. And there we go, the CPU is just dropped and we're loaded onto the GPU. So we should start to see some streaming now. Let's see how this goes. Okay, so I mean, it's a brief summary. It's not too bad. It seems a little bit more accurate than what we had before. Let's maybe ask for a bit of a longer summary while we're at it. So I'll just scroll up here. Just provide a summary of the above. See how it does. Okay, I mean, pretty good inference. Yeah, I mean, pretty good inference here. Let's try a detailed summary with 1L. Okay, not exactly right here. This is true though, they do discuss AI risks. And we've hit the token limit here just because I actually have limited it. So in fact, that's my fault. So let's adjust this here. put a max of 500 tokens. And let's actually move the temperature down to 0.1. So here we have a summary. Yeah, this seems good. Actually, Becky Quick speaks to them before the meeting, so it's kind of accurate that it's an interview, but not quite. Yeah, this is good. I mean, the quality here is very good. Let's check the memory usage, 63%. So this is really good. Yeah, again, we've reached the 500 limit, but this is good. I mean, the float is roughly accurate as well. So let's just try and push this model a little bit more and try go up to a longer context length. Let's see if we crash it. Yep. Oh, we managed to get it to work. That's great. That's really beautiful. And so we have the 13 billion model. This is great stuff. Yeah, this is really great stuff here. Now, there is some repetition here, but it manages to pull it back towards a summary. And it finishes off. So it even provides an end token. This is really pretty great. This is really pretty great. Now, folks, if you want a little bit more slick of an experience chatting with Jupyter Code Llama, then I recommend using the Pro Notebook, which is available for purchase with the link in the description below. It allows you to save chats, reload chats, and adjust the context length and upload files for discussion in a pretty seamless way. So let's just get started with this. I'm going to set it so that we use the 13 billion model. Let's just scroll down to where the model is loaded. Here we go. We'll change this to the 13 billion model kernel, and we'll say restart and run all cells. I need to close down this kernel here. Now we're being asked for context length. I'll just put in 32,000. That's what I want. I'll even put in 50,000 here. The doc will be shortened to 37,500. So here we go with the installations. Okay, and we now have the GPU loaded with the model, and we should be able to start streaming. In fact, we already have a stream. Sorry, I should be in the Pro notebook here. Okay, we have now loaded on GPU, and we should be ready if we scroll down to see here, Jupyter Code Llama Pro. This is going to be very responsive because we have 80 gigabytes. So we'll see very quick responses. Let's just upload a chat here and load that file. It'll be shortened and it'll be injected into the chat. We'll scroll down here and now say, provide a short summary of the Berkshire meeting transcript. And now what's happening is this is being computed. So all the tokens will be passed through the LLM. We'll then see the GPU spike as it starts to sample for the next token, where it'll be using the KV cache. So yep, that's the spike there. And this is not streaming. It's not set up for streaming. So it's going to wait until it's finished producing the summary, and then it will be printed to screen. We can just keep an eye on the memory usage here. So memory usage going up a little bit more again, just about staying within the memory allowance. Just shows you we couldn't probably push it much more. So still generating a summary. All right, so here we have, yeah, this is correct. There's a Q&A with the shareholders, future plans. So this is a pretty good summary here. I just want to highlight that I think it is important that you put in the right system message. So you can see back up here when, let's just search for system prompt rather. Here's where I've defined it. Yeah. So you're a helpful assistant and an expert on summarization. You provide accurate summaries of the information provided. I think that's pretty important. If you don't provide that prompt, you're probably not going to get the same summary quality. So just a little tip there. For those of you who want to stick around, just a few notes on achieving long context length. I think OpenAI and Anthropic are far ahead on this, but let me share with you what I've learned. The keys to getting long context length are memory and quality. In terms of memory, you need to use as large a GPU as possible to fit the long context, but also you want to use some tricks so you minimize your usage of memory. In terms of quality then, you ideally need to have a model that's been fine-tuned and can be extrapolated out to long context lengths. So let's dig in a little bit on that. When it comes to memory, you can pick a bigger GPU, and that's why I've shown you how to run one on RunPod. But you can also use smarter software. So flash attention and BetterTransformers. I'll describe that briefly, but it allows you to use less memory when computing the KV cache for attention, which is the part that is relevant to the context length. Now, there's one other thing here that I briefly talked about during the scripts, and it's GPTQ. Basically, that's a form of quantization, and it gives us a 4x saving roughly in the memory requirements. Instead of representing every single number with 16 bits, we represent numbers just with 4 bits. So the model is cut roughly in 4, and that also drastically reduces the memory that we need and also the memory required for quantization, or the memory required for inference. Now, just a few notes on flash attention. Attention is where in a transformer, a given position pays attention to what's in the previous part of the sentence. So if you have a sentence that says, hello, my name is Ronan, the word Ronan, when that's being predicted, it's looking back at the words, hello, my name is. The way it does that is by using a key matrix and a query matrix. Every position has a key and a query. And you multiply both of these to calculate the value for that position. Now, when you multiply two matrices together, each of which have a dimension that's the sequence length, you get an order sequence length squared dependence on the context length. So basically, if you store in memory the key times the query, that means you're going to have memory requirements that scale with the sequence length squared, because K and Q both have a dimension that depends on the sequence length. So the secret of flash attention, it's not a secret, it's an open source repo. The secret is to break down K and Q so that you never store the multiplication of both, you only ever store individual matrices of size sequence length. And the way this is done is by, instead of storing K times Q, it's recomputed as it's needed. And further, basically K and Q are split into smaller pieces, and each of those pieces, the K and its corresponding Q, are fed through the memory and computed all the way through to the answer that's required. So there's no intermediate storing of K times Q, which saves significantly on memory. Now, the next thing is quality. Llama 2 was trained on 4K sequence length, but Code Llama was trained on 16K sequence length. And even though it's called Code Llama, I think it's probably the best open source model just for doing normal language modeling. And the reason is because Code Llama is Llama 2. So it's got all the benefits of Llama 2, but it's got more training. And yes, some of that is code, in fact, 85%, but there's 8% natural language related to code, and there's even 7% of natural language. So I think in terms of public models, it's the model that has the best training for the longest context length. And so if you start off with the 16K model, it actually does a pretty good job extrapolating to 32K using a technique called rope scaling. Now, rope scaling has been pushed even further. If you look at new research, they've got a model that does 64K. They've got a model that does even 128K. It's probably got a better scaling algorithm than what Llama 2 and Code Llama use. However, it probably doesn't have the same quality of fine-tuning. And that's because the new research model is not fine-tuned for a chat, so it's harder to have a chat with the model. And second of all, it's got some long context length training, but that data set is quite limited in its scope. It includes some long books or passages. And one of the issues I found is that when I do run with a long context length on the new research, it will tend to have weird formatting where it's formatted like the page cover of a book, for example. But I think the blend of data that Llama has, and Code Llama in particular has, is what allows it to maintain this high quality as you get up to longer context length. Okay, folks, that was a bit of a whirlwind. All of the links are below in the description. A few summarizing tips. It seems that the 13 billion model does quite a bit better than the 7 billion, and it still does fit on that 80 gigabyte A100 on RunPod. You could also probably run 16K of context in Google Colab using an A100 with 40 gigabytes. Remember that flash attention and BetterTransformer are key, as well as the quantization with GPTQ. That's how you can run long context with a smaller amount of memory. And the last tip, make sure that you do put in a system prompt. That seems to guide the model quite well to providing a summary, whereas otherwise the model can ramble a little bit. Let me know questions in the comments. Cheers, folks.